Section 1.1 will explain how matter is classified. While the textbook only offers one learning goal, we've identified several more specific learning outcomes to keep in mind as you study the material. If you can accomplish the learning outcomes without your notes, you're more likely to enjoy the greater chances of success on the exam. Let's begin. In chemistry, we study matter, energy, and the changes they undergo. All matter in the cosmos is composed of about 100 elements, all formed in stars. It's rather humbling to realize that we're all made of stardust, studying stardust. Elements are the simplest form of matter with distinct chemical properties. Elements cannot be broken down further without changing their identity. If you were to take a sample of an element, such as iron, and split it repeatedly until you arrive at the smallest amount of an element, you would be holding a single tiny atom. Chemistry works because the atoms have different properties that lead them to form bonds with other elements to form compounds. For example, sodium atoms interact with chlorine gas to form table salt, NaCl. Table salt has chemically distinct properties from sodium, a solid metal, and chlorine, a greenish-yellow gas. Regardless of whether you get your salt from the top of the shaker or the bottom, you can expect sodium chloride to have the same definite composition or ratio of atoms in every grain you taste. Because the composition of elements and compounds are the same throughout a sample, we classify these as pure substances. Let's examine this figure. On the far left, we have two examples of elements. In the early stages of your chemistry career, you'll find elements are monatomic, or composed of single atoms, or as diatomic elements, where there are two elements bound together. There will be 7 diatomic elements to memorize a little later in the course. In the middle column, we see two examples of compounds. Compounds will have at least 2 types of elements bound together in a specific ratio. In the top example, the ratio is 2:1, while the bottom has a 1:1 ratio. Finally, we can form mixtures from any combination of elements or compounds. 2 or more pure substances can be physically combined to produce a mixture. The components of a mixture are not chemically bonded to each other and can be separated from one another by physical means. Mixtures do not have definite compositions and can be either heterogeneous or homogeneous. In heterogeneous mixtures, the substances that make up the mixture are not uniformly mixed, so 2 samples taken from the same mixture might have different compositions. Let's take a minute to apply what you've learned. What are the components in the top mixture? What are the components in the middle mixture? What are the components that make up the bottom mixture? Homogeneous mixtures are also called solutions. Solutions are combinations of any 2 phases, such as the atmosphere, which is a gas-gas solution, metal alloys, which are solid-solid solutions, and the solutions we are most common with, aqueous solutions, where water is the major component. Aqueous solutions can have gases dissolved in them, such as in carbonated beverages. They can have other liquids dissolved in them, such as water and vodka, or they can have a solid dissolved in them, such as sugar-sweetened tea. This classification tree is a useful graphic for organizing how substances are classified. I suggest adding definitions to this graphic with examples to help you study. If the percentage of carbon in a small box of the pure substance sucrose is 42.1% carbon by mass, would you classify sucrose as an element or a compound? What is the percentage of carbon in a large box of sucrose? Let's make sure you really understand the material by examining the relationships between these definitions. I'll read a statement, then you decide if the statement is true or false. Every compound is a pure substance. Every compound contains two or more elements. Every mixture contains two or more compounds. Every pure substance is a compound. All mixtures are homogeneous. As always, I'll leave you with the parting thoughts of the authors.